Hi, I'm going to try something a little bit different this time. I'm going to give you some problems to work on, and then I'll go through the answers of each one. And so that will allow you, when you can go to the problems you want to see the answers to, or, however you want to do it. So pause, here are the problems, do as many of them as you would like, and come back and I'll walk through each one. Um, so just want to go through, this is the law. When you have a multiplication, you add exponents. And when you're dividing inside the log, you subtract the logs. When you take a power, a base to a power, a number to a power, inside the log, you can bring the power out. So that's how we get that there. The log the log base a of 1 is 0. That's because a to the 0 is 1. Log base a of a is 1. That's because a to the 1 is a. And the log base a to the n, you bring out the n, you get n log a of a. Log a of a is 1, so you just end up with n. This is the inverse rule where you cancel. I just you can cancel those out. And this is the change of base rule right here that allows you to evaluate things like that. And I'm going to add another problem down here. So I'm going to add a 10th and 11th problem. We want to do we want to look at the log 5 of 124, and we want to look at the natural log. Sorry, I don't want to do that. We also want to look at the log base 9 of, let's say, 100. Okay. So anyway, so work on as many of those as you want. I'm going to go back and walk through them each by one by one, and feel free to, of course, when you come back, feel free to fast forward. Okay. I have an annoying thing here, so I'm just going to do that. Good. Okay. Okay, so here I go. So pause, work on the problems, and join me. Okay. Okay, so hopefully you've been working on the problems. So I'm going to first simplify log 91 times x. And so that's the first one. Okay, so that's going to be, I'm going to use this rule, log u times v equals log u plus log v. When I multiply the bases, I add exponents. So I'm going to add these. So I know there's a plus. So the first piece is going to be log base 10 of 91 plus log base 10 of x. Okay, that's the first one. Okay. So the second one. The second problem is the log of x squared plus 1 divided by 7. And the rule I'm going to use is this rule. Log u divided by v. That's my u, that's my v. Sorry, this should go like this. And again, when you divide powers, you subtract the exponents. So that's the formula I'm going to use. So again, I'm going to end up subtracting. So I'm going to have a subtraction. Sorry, I should put the equal sign there. So this is my u, that's my v. I'm going to get log x squared plus 1 minus log of 7. Okay, and that's it. You always look to see if can I factor, can I do anything more to simplify, and I can't. Okay, so the third one is the log base 7 to the 5th, and I'm going to use this rule. Log base a of a to the n is equal to n. Now I'm going to go through this a little bit more detail. So again, so I know that this is going to be equal to 5, and I'll go through the steps. So this comes down, and that's 5. So I'm going to have this is equal to 5 log 7 of 7. And we know that this is equal to 1 because we know that if you have log base a of a, you get 1 because a to the 1 is equal to a. So this is just going to be 5 times 1, which is 5. And again, you don't need to go through all that. I just wanted to go through it. You can go directly to this using this rule. Okay. So here's the fourth one. Log 7 of 49. Well, that doesn't look like you can do anything with it, but I think about what 49 equals, and 49 is equal to 7 times 7, which is 7 squared. So I can use this one again with a equals 7, and this is just going to be equal to 2 times this, which is going to be equal to 2. I just bring the exponent, and that's all that equals. Okay. I think I can do one more on this page. 5, it's going to be log x squared times z cubed. So this is my u, and this is my v. It's a multiplication, so I'm going to begin by using that formula. And so this is going to be equal to there's going to be a plus, and it's going to be log of u, which is x squared, plus the log of v, which is z cubed. Okay, and now I can use this law, log a u to the n equals n log a of u, and I can do that here. I can bring this 2 down and bring this 3 down, over here in front of the log. So this is going to be equal to 2 log x squared plus 3 log of z. Okay. Oh, you can't even see that. I'm really sorry. It was really stupid of me. I just wasted your time. So let me go through that again. So I want to do the log of x squared times z squared. That's u times v. So it's going to be a plus using this rule. So I get log of x squared plus log of z squared. And then I can bring the exponents down. So I bring the 2 down in front. Oops, that 2 shouldn't be there. I made a mistake. So 2 log x, 3 log z, 3 log z. Okay, and that's it. So again, sorry for that screw up. Okay, I'm going to go back and do another one. So I'm going to do number 6, log base 11(1). Again, I'm going to look at my log formulas, and it looks like this one right here. That's going to be equal to 0. And again, the reason is that 11 to the 0 is equal to 1. So 11 to the 0 is equal to 1. So that's how we get 6. Number 7, it's a more complicated one. We're going to get log x squared times z cubed all over y to the 5th. So we get that one. So again, I'm going to use, this is going to me, this is a division and then a multiplication. So first I'm going to use this one with this is my v and that is my u. Okay. So again, I'm going to use the rule log u over v is equal to log u minus log v. Okay. So again, this is going to be equal. The first thing is going to be, there's going to be a minus. It's going to be the log of the top minus the log of the bottom. This is my v. The top is my u. So now I can do a couple of things. I'm going to separate. Now I have a multiplication here, so I'm going to use this rule. Log u times v is equal to log u plus log v. Okay. So this is going to be my u, this is going to be my v, it's going to have a plus. So this is going to become log x squared, my u, plus log z cubed, minus, I can bring the 5 down, 5 log y, and I'm done with that one. So the last and final step, remember this is simplified completely. I bring the exponents down. I get 2 log x plus 3 log z minus 5 log y. Okay, so that's number 7. Let's look at number 8. Number 8 is going to be 9 to the log base 9 of 52. Again, the 9 as a base and 9 as a log, those are inverses, those cancel. I get 52. And I did that just thinking of inverses, but if you want to look at the rule that I used, let's get it so you can see it here. Let's do it here. I use this rule right here, where the log and the power cancel and just get the u. Okay, that's just the inverse. Okay, number 9 is going to be more complicated, so I'm going to do that on the next page. Okay. So number 9 is going to be the natural log of 2x squared plus 1, of 2x plus 1, I'm sorry, y cubed times z cubed. And again, I think of this as a division first, so I'm going to use the division rule. Log of u over v is equal to the log of u minus log of the bottom. Okay, that's my v. That's my u. Okay, I get a minus, so this is going to be equal to the log of the top, my u, minus the log of the bottom. Okay. These are simplified completely. This one's done. This one is going to be multiplication. So I'm going to use this rule. Log of u times v equals log of u plus log of v. Okay. So I'm going to use that here. There's nothing more I can do to the 2x squared plus 1. So I just, and remember this minus, everything I do here is going to have a minus sign in front of it. So this is going to be the log of u. U is my first term, y squared. V is my x cubed. There's going to be a plus. So it's going to be natural log of the first one plus natural log of the second. Okay, remember on this one, I used the multiplication rule, but I'm going to apply this minus sign to everything. But I'm going to do that for my last step. Bring the 2 down. Again, I'm using this rule. The log of u to the n is n log u. Here, let me just separate those from everything else. So the 2 is going to come down. The 3 is going to come down. And then I could apply the minus sign. And then the next minus sign. Okay, so I got 2 more, and these are going to use the change of base form. So I have 10 is going to be the log base 5 of 124. 11 is going to be the log 9 of 100. And I'm going to use this form here, that the log of a to the u is equal to the natural log of u over the natural log of a. Notice I could do this one too. The base 10 log of u over the base 10 log of a, but I want to use this one just to practice the natural log. Okay. Okay, so this one, I'm going to write it as the natural log of the top, what I'm taking the log of, over the natural log of 5. And I'm going to go look these up in a minute. So we'll go online and do that. So for this one, again, I'm going to do this. It's the log of what you're taking the log of, 100, over natural log of 9. That's my base as a 9. And again, I could have done it this way. So I'm going to go to the, I'll go here. Okay. I want to go here to the calculator. Okay. And I'm just going to do each of these right here. So I'm going to do the log of 24, divided by the natural log of 5. And that's going to give me 2.995 dot, 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 but we'll round to 2995. Okay, now the second one was log, let's clear that. Okay, the second one was log of 100 over log 9. So we'll do this one. So that would be log of 100 divided by the log of 9. Let's see what we get. We get 2.095. That's just a kind of a quirk. Okay, so I'm going to go back to the sheets. So the answers. And so again, notice that we have this equaling this. That means that 5 to this number is this number. So 5 to 2.995 is going to be about equal to 124. And again, I want to look at this one. I have log 9 to the 100 is equal to this. So that means that the base to the exponent, 9 to the 2095, is equal to 100. Now these make sense to me. 5 cubed is 125. That's almost 5 cubed, so it makes sense it would be 124. 9 squared is 81, so with a little bit more change, you're going to get closer to 100. To me, that makes sense as well. Okay, those are the examples. I hope they were helpful. Please let me know if you have any questions. Sorry for the abrupt end to the first video, and thank you.